It's recording. So let's start off with just understanding some basic things, and then I'll try to move to a graphical sense to see if you can link the two, okay? So you learned in the last session, some of you would have revised on year 7 content where we learned to plot coordinates. Now the coordinates, we usually say in brackets, there are two numbers that you look at. You look at the horizontal number, is the x-axis, so the x is horizontal. Then you look at the y-axis numbers, which is the vertical, right? Sometimes I tell students that it is your left or right is what x represents, and then y represents up or down, okay? So the numbers will tell you, do you move left, negative moves left, positive moves right. If the y values are positive, up, and then negative goes down, yeah? So there are two number lines. That is your X line and your Y line. So this is what you would have seen in year 7. So I'm just going to zoom out. They call this the X-axis number line. I'm just going to move this so I can come closer to the screen. So they call this your X-axis number line. So you counted in primary school. You started 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will learn to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's called counting numbers. Then you learn to add, subtract, multiply. Essentially, you were working in this timeline. Then you get to year 7. We then introduce, well, you can subtract further than just up to 0. So you learn negative numbers. So last year, this is what you were learning. You were learning that side. Together, you can have vertical numbers and you can have horizontal numbers. That's what the X and what the Y represents. So with two numbers, so for example, if I asked you to plot the coordinate 1, 3, that 1 there represents on the x-axis, so you go x first. 1 is positive 1, so I'm going to the right by 1, so here's 1. So right by 1, and then 3 is the y value, so it's up by 3. So here's 1, 2, 3, so here's 3. So 1 across, up by 3 gives me this point, 1, 3. Okay, so that's what you learned last year. And then we revised it last session, but also that's exercise 9A. So I'm saying you can skip 9A because that's all you need to know. So you just need to know how to read a coordinate. Cool? Okay, let's plot all the other coordinates. So on your paper, just quickly plot in yourself for yourself, -5, -7, -1, 8, 0, -1, and 6, 0. And then I want you to tell me, do you see a pattern? Or is it just a random set of coordinates? Okay, so I'm going to slowly plot. Check your answers as I'm plotting them up. So -6, -7.
No, you got it all wrong. Nope, you got it all wrong. Nope, you got it all wrong. No, actually, magic of that. Keep correcting you. This actually on the recording. Actually, he just going to
Oops.
Have it.
All right. Can I get a show of hands? Who got out of those 5 coordinates? I did the first one. Out of these 4, did you get 4 out of 4? Correct. So you should have this point, this point, this point, this point. These 4. 4 out of 4, hands up. Okay, even if you haven't finished it, but just being confident, knowing that you could have done 4 out of 4, hands up. Okay, good. So if you're confident you could have got 4 out of 4, very good. If you weren't, that is 9A. So 9A, then you can go back and revise that. So if that skill there was unsure, that's the year 7 skill. I want you to go back and do 9A. But if you got that, 4 out of 4, move on. Don't do 9A. Okay? All right. Now, that was plotting. Pretty straightforward, right? Then we say, okay, well, let's look at a pattern of coordinates. Let's have a look at this. Tell me if you can see a pattern in the next one. So I got coordinate 1, 0, 1. Wait. 1, 2, 2, 3, 3, 4, and like Attila's been calling out, 19, 20. Now that was easy, right? Because there's a pattern that you intuitively know. But what I want you to train, boys, please don't speak while I'm speaking. What I'm trying to train you in 9B is, what is the rule? What was the rule so that you know what the y coordinate was? You see, as soon as you know x was 0, you knew this was 1. When x was 1, you knew this was 2. When x is 2, you knew this was 3. And so when I asked if x is 99, how did you know y was going to be 20? Because if I said, for example, what if I gave another example? I said x was 99. What would the y coordinate have to be? 100. So you're doing something in your head, but you got to spell it out. So today's exercise is about you finding that rule. Because that rule, I'm going to show you visually what it looks like on a graph. Because that's what's hard about students. They cannot take pattern and put it visually. The disconnection between visual aspect and an equation, they're two very separate things for students. But technically, they're the one thing. Yeah. So what's the rule? How do we make sure to know that this is going to be 20? What did you do in your head? So if you knew x was 99, how did you go from 99 to 100? What did you do in your head?
Add 1.
Add 1. What did you add 1 to?
X.
To x. So the rule, can you see here, it didn't have to be 99. I could have done this. I could have said, if this was x, what would this one have to be? And that's where a lot of students get confused. See, if I said 99, you all said 100. But funny enough, when I ask students, if this was x, what should this one be? Take your time. See, this one you knew. I said 99, you said 100. Now I'm saying, well, what if this was x? What would this one be?
1x.
See the disconnection? This is why algebra and calculation is tricky. So 99 you can do. How did you get 100? What did you do? Plus 1 to the 99. So if this is x, this one must be x plus 1. So what's the rule? The rule to get the y coordinate. Boys, this is so key. I already told you, year 9 is going to be tricky, and I'm trying to show you. I'm explaining it detailed. You're never going to get this kind of explanation again. Yeah? So right here, that y coordinate was the result of you intuitively adding the first number by 1. So that's what I said. I said, whatever this number is, x plus 1 to get y. That's why in this exercise or chapter, you often see an equation with the y equals something. That's the reason why they do that, because they're trying to get you to figure out the rule for the y coordinate. So this rule here, fill it in, it should be x plus 1. So to know what the y coordinate is, to know what that y coordinate should be, the rule was whatever that number is, you're going to add 1 to it. That's what the rule says. X plus 1, write that in. I want you to do the same for part B. Look at the pattern. Shh, boys. 0, 0. So 0, then it became, when it's 1, it's 2. When it's 2, it's 4. When it's 3, it's 6. So when it's 21, what's the y value? And the key part is, can you come up with a rule? Can you come up with the pattern?
It's timesing the number previous to itself.
By
2.
By 2, very good. Okay, so if this is 21, what should the number be? 42, very good. So this is 42, but the key step is to convert it into a formula. So this is where the hypothetical comes in. This is where algebra comes in. If I said this was x instead of 21, so 21 you knew was 42 because you doubled 21. So if this is x, what should this one be?
2x.
2x, very good. So you times it by 2, x times 2 is 2x. That's what you did in chapter 5. So last term, chapter 5, x times 2 is 2x. That's why you were learning that. Yeah? So the rule is to find the y coordinate. This y coordinate, it was the result of timesing 2 to whatever the previous number was. So that's why the rule should be 2x. So far, so good? Okay, so this is sort of an intro. That is what the purpose is. When you see these equations, you have to understand you're actually finding this y coordinate. Why do you want the y coordinate? So that you can plot these points onto a Cartesian plane. Okay, so if you can plot it, you can visualize it. Okay, so let's do one example. Let's do one example so you can practice picking it up. Now, this is called a table of values. I'm going to write it down and you should write it down as well. The name for this is called table of values. You did this last year as well, but maybe the explanation as to why we do this wasn't explained, so I'm going to explain this year. This is called table of values. Notice you've got X, you got Y. This is just written, and I want you to listen to this bit here so that you can interpret it. Table of values is telling you when X is 1, the Y corresponding to that is 4. So what that means is instead of writing this, 1, 4, we write 1 up here and then 4 for the Y. The reason why we do that is because if you write brackets, it gets really confusing if I wrote it like this. 2, 5, 3, 6, 4, 7, 19, and now I'm questioning what's there. So this is longer to write. So we use table of values just to look at a pattern. Now, can you see a pattern? Let's look at the pattern. You got 4 if it's 1, 5 if it's 2, 6 if it's 3, 7 if it's 4, and Nick, you just mentioned the rule is?
+3.
+3 to what though?
To Y. 2x.
2x, very good. So whatever x was, whatever this number was, you add 3 to it. Can you see the pattern? Add 3, add 3, add 3, add 3. So there's a pattern to it. So the rule is, if it's whatever x is, whatever the x number is, you're going to add 3. Okay? 19 plus 3 gives you? 22. So 19, 22. Now, this table here, I don't want you to just see it as a table. It's actually a set of coordinates. You got 1, 4, 2, 5, 3, 6, 4, 7, 19, 22. Okay, now copy that down first, and then I'm going to now plot it onto a Cartesian plane so that you can see what does y equals x plus 3, this equation, what does this equation look like? Because that is the hardest, to me, one of the hardest things that students struggle with, to be able to link an equation to the visual aspect. I still train my year 11s till this day to be able to visualize an equation. That's how hard it is. Okay, and that's where a lot of students give up because it's too hypothetical. You guys can do it when it's numbers. It's like 19 and 22, you can do that. But when I use x and y, suddenly I lose a lot of students. Yeah, so let's visualize it. Let's plot these coordinates in. So I want you to see here, I'm going to go to Desmos. If you've never used it before, type in DESMOS onto Google, and this comes up. Now I'm going to type the coordinates in. We had, the first one was 1, 4. So I'm going to label it. There's 1, 4. Okay, so 1 across, and then 4 up. Okay, I'm going to zoom in. I'm going to change the axis so you can see step 1s. There we go. So that's 1, 4. You got 1 point. What's the second coordinate again? When it's 2?
2, 5.
2, 5, because you add 3 to that number. So you go with 2, 5. And then I do the same thing. 3, 6. Wait, is it 6? Yeah, it is 6.
7.
Then we've got 4,
7.
4, 7. Okay, now, I want you to tell me what picture is coming up, because there's a picture that's happening right now. If you connect the dots, what are you getting?
It's going up.
It's going up, but what kind of picture are you getting? It's a
Incline.
diagonal line, incline line. Very good. Now, the language, this topic, why did I call it linear equations before? So at the top, write this down. Linear means straight lines. This actually means straight lines. So linear equations. This is what is going to challenge a lot of year 9 students next year at term 3. So term 3, year 9, term 3, all the algebra I taught last term links into this idea. Now watch what happens. So you just told me you expect a linear equation. Oh, sorry, I'll leave it there. Linear equations. Okay, so linear means straight. You were right. It was a line and it's inclined, right? Watch what happens when I type the rule. So you guys told me before the rule was y equals to x plus 3, right? That's the pattern. So watch what happens here. If I go back to Desmos and I tell the calculator to follow that pattern. I say y, so whatever the y coordinates are, because they know this is the y-axis. If you want to know what y is, I'm going to say take x, add 3. So I'm going to write y equals x plus 3. And look at that. You see that straight line? That actually crosses through every single point that you just said. But there's also more points in between. It didn't have to be 1 plus 3. It could have been 1.1 plus 3. So that's why there's all these infinite possible points in between. So if I asked you before, if I said, what if this number was 2.5? What would this number be? If x was 2.5, according to your rule, what should be the next number be? 5.5. Because you had 3. Yeah, so the rule was add 3. Can you see now, if I tuck this in, if I actually put in that coordinate, if I said 2.5, 5.5, according to that rule, it's right there. It's included. So why do we learn to draw this straight line? Because you didn't need 1, 2, 3, 4, 5, 6 points or 5 points to draw a straight line. What's the minimum number of points you need, logically, to draw a straight line? You need 2. Think about it. If I drew 1 dot on the screen, if I drew 1 dot, there's no way you can draw a straight line. You did not need 5 points to draw a straight line. All you need is 2. And if you connect them, and because it's straight, it's always going to be in that pattern. So the study next year is that you're not going to learn to do 5 points. At year 8, you're doing 5 points onwards. It takes a long time to do it. But at year 9, you learn to do 2. So this term, in the next 2 weeks, I'm going to teach you how to draw a straight line from an equation with just 2 points. Because what you just did just now was you did 5 points. You see, you got an equation. You needed 1, 2, 3, 4, 5 points to draw a straight line. It takes too long. At year 12 level, we do that in a few seconds. Okay, so we don't do what you just did. That takes too long to do. Okay, so it's an intro into algebra, equation, and graphing. You see what I mean why it's tricky? So next year, that's term 3 stuff. Yeah? So today's lesson, all you're practicing is to get that equation and then learn to slowly plot each one. You should get a straight line for all of them. So every one of the equations you do, it should look like a straight line. All right, let's try another one. Let's do this one. All right, same thing. See if you can figure out the pattern. X is 1. This is 2. 2, then it's 4. 3, then it's 6. 4, then it's 8. 38, very good. What's the rule, Xavier?
X times 2.
X times 2, very good. And x times 2 is the same thing as writing 2x, which is what Nick said before. And watch what happens now. I'm going to write it again. Let's do the same thing. 1, 2 actually means coordinate 1, 2. 2, 4 actually means coordinate 2, 4. This is 3, 6. This is 4, 8. And this is 19, 38. If I plot all of these onto Desmos again, and you'll see the same pattern, your rule should actually cross through all those points. Let's do it again. I'm going to delete all of these, and we're going to do it all from beginning again. So, 1, 2, 2, 4, 3, 6, 4, 8, and the last one was 1938, was it? All right, I'm going to label them all so you can see all the coordinates. And the rule that Xavier said before was x times 2. Can you see that? You get 1, 2, 3, 4 points. Actually, 1938 is even further up. So if I zoom out, it's right there. But you see the pattern, when you type y equals 2x, that's all the possible numbers that you could have tested. But you only needed 2 to sketch a straight line. Does that make sense so far? Yeah? Okay. So today's lesson, that first skill is to work out the rule. First skill is to work out the rule. Okay, so skill number 1, find rule. Let's go with now skill number 2. Turn over the page. Turn over the page. Now, the first one was to see a pattern. This is what my year 9s generally struggle with, and even all the way to 11 and 12s. The struggle is this. See that equation? A lot of students look at that and they're like, I have no idea what that means. Again, this is the same thing as what I just taught you. They now gave you the rule. Your job is to find the coordinates. See, unlike before, I gave you the coordinates. Now you're working backwards. Now I want you to find the coordinates so you can sketch a straight line. So let's follow the rule. The rule says to find your xy coordinate, if x is a certain number, to find y, it says 2x plus 4. Now using your algebra understanding, what does 2x mean again?
2 times x times 2.
Good. So you times 2 and then plus 4. Now according to BODMAS, which one do you do first? Times 2. So you times 2, double x first, and then you add 4. So this is where we say, well, to find the y coordinate then. So if you want to know y, it says to find y, double the x, add 4. That's the rule. So here we go. Let's start off with, let's do positive numbers first because it's a bit easier. If x is 2, so according to the rule says if x is 2, you first double the x, double x. What's double of 2? 4. And then you add on 4. Does that make sense? I'll write it again. So it says 2x plus 4, but since we now know x is 2, 2 times 2 plus 4, 4 plus 4 gives you 8. And a lot of students do this at year 8 and then year 9, but they still don't know what this actually means. All it was you just figured out when x is 2, y coordinate should be 8. Just the same way as I asked you before. When I said it was 19, you said 38. If I said it was 5, you said plus 3 was 8. Same thing here, except you're following a 2-step equation. Okay, so let's do the same thing for the next one. What if x was 3? If x is 3, what should the y coordinate be? Follow the pattern. Rule says double x times 2 to x and then add 4. So if x is 3, what should y be? 10, let's check. Double 3 is 6. 6 plus 4 is 10. Are we following? Does that make sense? Yes? Usually after y, you should be able to see a pattern. It went from 8 to 10, so how far did I have to go? Have a think. From 8 to 10, how many units? 2. So if I went back, actually that's 0. Sorry, that's different. My bad. We still follow the rule. Next one. If x was 0, so if x was 0, what should the y value be? So double the x and then add 4.
4.
Very good. So you should have the coordinate 0, 4. What about, now we're going to negative numbers now. Same thing again. What if x was negative 2? What should the y coordinate be? 2. Let me think. Double negative 2 is, let's write it out. Double of negative 2 is negative 4, and then you add 4. So what's negative 4 plus 4? 0. Very good. So negative 2, 0. Then be careful with the negatives on this. This is why everything you've learnt all the way up until the end of year 8, that's why it ties into this one topic. Yeah, negative numbers, fractions, decimals, you're going to do it all in this one topic. That's why it was important to know your foundation. Yeah. So here, same thing again. Double of negative 3. Then add 4. What's double of negative 3? 2 times negative 3 is? Negative 6. So 2 times negative 3 is negative 6. And be careful, negative 6 plus 4. Think about your number line. Negative 2. Very good. Okay, so this is where practicing that negative numbers is going to be important. So negative 2, and what does that mean? That just means when x was negative 3, the y coordinate is negative 2. You see, I keep emphasizing that because a lot of students, when they look at the table, they don't see this. It's 1, 2, 3, 4, 5 coordinates that you're solving for. You can do that even at a year 11 level. You can still do that. I can give you a rule that my year 11s were just doing today. They were doing x cubed plus 6x minus, I think it was 6x squared minus 8x plus 1. You can still sketch this graph if you follow what I just taught you. You can still actually sketch that using this. But we obviously have more efficient ways at year 11 level to sketch that graph. Okay, that graph is like a very curvy graph, whereas you start off with just a straight line. That's what we're training you to do. Okay, so we're training you to link an equation with the visual aspect, and that is the most challenging skill to teach students, because you guys haven't actually ever thought of it abstractly. You only did it with numbers. You never did it with a letter. That's why it's tricky. Okay? All right. Now let's put this into practice. So we started off with y equals 2x plus 4. So right now, most of you do not have a picture in your head. You don't know what this looks like. But we've now got 5 points. We've got -3, -2, -2, 0, 0, 4, 2, 8, and 3, 10. Can you plot that in to see if you can see the picture now? Plot that in. I'm going to pause the video. Can I get a show of hands if you got something like this? It should look like a straight line. It should connect with a pattern. -3, -2, -2, 0, 0, 4, 2, 8, 3, 10. Show of hands if you got that picture. Thank you. We've got 1, 2, 3, 4, 5, 6. Good. That is the skill that we're learning today. Okay? Shh. Thank you, listening. Shh. Okay, so let's recap the skills that I want you to learn from today's lesson. Okay, so I'm not going to go too much deeper now. The skill that you're practicing as an intro for 9B is 1, can you find the rule? Okay, so they give you a set of table coordinates and your goal is to find the rule. Step number 1. Step number 2 is actually the key skill that we're trying to practice here. It's this one. They will give you a rule. They want you to use table of values as a tool. Boys,
Sorry.
thanks. They want you to use a tool to help you sketch. Because later on, in year 9, you just get this. They will give you this. And they say sketch. That's the problem. So in year 9, that's the question. Sketch that graph. And label the coordinates. That's what they'll say. And a lot of students will then struggle here. They learn all these techniques. They learn all these techniques and they don't know how to do that. But you've done it. You're doing it right now. You've done it in year 7 and you've done it in year 8. You're doing it in year 8. You just don't realize that you're learning to sketch a straight line equation. So this here, this table is only to help you get 1, 2, 3, 4, 5 points. There is one very logical thing that a lot of students overlook. So I want you to listen to this bit. Listening? Your textbooks usually go from -3 to 3. The reality is that you don't have to do -3 to 3. You can choose any number you want.
That's 2, bro.
Now I'm going to say that again, listening. When you're doing these table of values, remember it's a tool. It's not an absolute. You don't have to do it this way. I use -3, -2, 0, 2, 3. Your textbooks will probably do 1, 2, 3, 4, 5, 6, 7, 8, and so forth. Boys, you don't have to do it that way. The whole point is you just need 5 coordinates just to prove that it's a straight line. Okay, so when you're doing the questions, don't question why the numbers that they are. These are just random. You can choose any number you want. Okay, obviously the smaller numbers, the easier it is to calculate. All right? So when you're doing the textbooks, don't worry about these numbers, just follow what they give you. But the point is you're trying to get 5 different points using one rule. Okay, so that's the second skill. The second skill is what I'm really looking at because it combines 9A and then the understanding of converting an equation into a picture. That's what you're trying to do. So I want you to eventually do something like this. I want you to be able to hopefully pick up a pattern that I can give to you. Say I give you y equals 2x plus 4. You'll eventually be able to see that. That's the link. Over time, you can look at the equation without the table and you see that. Because that's what I see. See, when I think of like y equals -x, I already know it will go down. So if I go y equals -x, see it goes down. I can picture that. See, if I say -x plus 5, I know it goes up, but it still goes down. So it shifts the graph up. So if I did plus 10, it shifts it up. If I said plus 30, I can picture it going up, right? That's the skill eventually that you get an equation and you can picture the graph. That's the goal, okay? So for today's lesson, 2 skills. Skill number 1 is this one, identify a rule. Skill number 2, is to learn how to plot. Follow the rule to get 5 different points to plot. That is essentially the hardest skill that I want you to learn. Okay? That's it for today's lesson. It's currently 2:37. You should have at least half an hour to go have a go with 9B. Okay, have a go with 9B. I'm going to stop the video.